Hello, my name is Michael Tapia. I'm going to be going through this mock. I'm going to go through this mock session and do the best I can. I don't have everything around. I don't have the NXTs, but I am going to use some props around to kind of explain, like I'm talking to a class. For this one, I have a headset going on because there's a lot of background noise, loud neighbors, and there's also I live in an apartment, so they're cutting grass. So I was giving that explanation. I'm going to be wearing a hat. This one just keeps it a little comfortable on. A hat doesn't leave a line from a headset would do. Okay, so to go ahead and start off, introduce myself to the class. Hello, everyone. My name is Mr. Michael. I'm going to go ahead and be going through some spike. We're going to go ahead and do some robotics. So to start off, I'm going to go ahead and teach you guys the basics. And here where the props come in. This right here is just a little battery port. I connect everything. This is our little spike device. We're going to be using this, I believe it's an NXT or EB3, one of those two. It's the only ones I can find. So we're going to be using this, and we're going to be plugging all our code from our computer to here so it makes something move. On top of it, here's the one wire that we're going to be connecting it to, and that wire is going to go to this little motor. And we're going to go ahead and plug that in right here. So to understand how this works, here is the very heart of what makes our motor work, or our robot work in general. NXT holds all the code. It's going to run through this wire, and this is the motor that's going to make it move, whether we want to make it move forward, move it backward, at a certain speed, as well as we can, and we have two of these. We want to have two wheels on each side. Maybe you want to turn to the right, pretend like there's a motor over here on this side. You want to turn it to the right, you just turn off one side and it rotates. Actually, it's backwards. You turn off this side and move forward. I almost forgot that it's the trick is whatever motor you turn off, the opposite will go. So I think I don't remember, I haven't worked with one in a while, but we'll see that together in class. So now that we have this out the way, just to kind of briefly go through it. Now, what is code? Now, code is nothing more than a series of instructions. Gonna have some paperwork over here. Looking back and forth, that's what I usually do in class when I'm teaching. Uh, with this code, all right. So our NXT and its code. And what exactly is code? It's nothing more than instructions to tell your computer what to do. Simple as that. It doesn't get any um, simpler than that. You can use code for different things depending what it is, but because we are going to be working robotics, it's you're mostly going to be going back and forth and turning off motors, and that's it. Now, I do not have the Spike IDE or what Scratch uses, so I'm going to be teaching you guys Python, basic Python, the most basic data types, and data types, I'll get to that, and it's going to be what's going to use to make our motors run. So to start off, let's get over to, all right, so data type, I mentioned that. I want you guys to imagine this box right here. This is a container. This container, we're going to give it a name. In this case, I'm going to give this container, which is currently unnamed, we're going to call it we're going to call it my name. Now, what's my name? My name is Mr. Michael. And this right here is my little name tag, Kozowski. So I want to give this a value. Now, a value is basically saying, okay, my name. What does my name mean? Or what is it? What is my name? Basically. And this could go on. It could be a name. Uh, it could be words. It could be numbers. It could be a true or false value, which is going to be very important. True, we call those booleans. So that's what we're going to be doing here. I'm going to go ahead and give this value, this empty box. I'm going to give it a value, and it's going to be called. What is the name? This is called my name. My name is going to have the value of Mike Wazowski, this little name tag. So I store it into here, and now everywhere I go along the codes, all the instructions, if I need to put it, I just type in my name, the words, my name, the name of this box, and and it makes it way easier. What if there's a number? Maybe there's a number I want you to think 1, 2, 3, 4 or 3.14. Instead of writing 3.14, 3.14, 3.14, it gets very annoying. So we just give it a simple name. 3.14, what's it? That's that. It's pi. That's the number for pi. So instead of saying 3.14, we just say, okay, pi, we put pi here in our code, we put pi here in our code. That's all you're doing. You're just always doing it. And that's kind of the visualization of it. But I'll actually show you guys code, basic code for it. And let me see if I can get that for you. I'm gonna share my screen. Give me like 2 seconds. All right, perfect. I hope the camera picks up my hopefully it picks up my face. I should. If not, I do apologize for that. So to start off again with our first example, integers. Integers are nothing more than whole numbers. Whole numbers, 1, 2, 3, 4, 5, 6. In this case, I'm going to go ahead and use my age for this. So my age is and then the integer that I want to display on screen. This is a very basic way of like this is the way to go ahead and print out something, but I'm only doing that so you guys can see it actually work. So with integer, I'm gonna say I want to show my age. My age, I'm 23. So what I'll do is I'll go ahead and I'll run it, run the code. It should pop up in the terminal, but as it's running, it's a little slow. So as it's running, it's gonna read through and read the code one by one, all this up top around here, and then it eventually displays it. My age is 23. Pretty cool. We can make it do a lot more than that. We could type a bunch of stuff like there are this many fingers in my soup. And then how many fingers are in my soup? We just type in integer 23. Again, I could go as far as into this big of a number. Imagine typing that over and over and over. And of course, you could just copy and paste it. That's boring. But we use this integer, we use this variable integer. Well, the name of it. That's our little box right here. Our box is called integer, and what I'm putting inside is this big old number. That big old number is this. I'm storing it here, and now I can tell my code there are this many. Now I tell it to print out. There are this many. Oh, fingers. There are this many fingers in my soup, and instead of typing that big old number, I just give them the box. I'm giving my code the box that has the information, and the code looks inside the box and goes, big number. Okay, here we go. It's computers, they're just cool like that. All right. So that kind of goes down to there. And so that explains integers. They just it just means that they hold numbers. And you know it because there's the numbers next to it. So I'm gonna comment this out. And by the way, commenting, uh earlier you might have seen this, or there's a bunch of green little hashtag right here. That's what we call a comment. It's designed, it's meant for the computer to ignore, and it's meant for programmers like us to look at this and go, okay, that's for me. That's for the programmer. I'm leaving a message. Maybe I don't know. I got maybe another teacher, Mr. John or Miss Patricia. I gotta leave a note for her. And I tell her this variable is how many fingers are in my soup. And so so in case I leave this aside and Miss Patricia wants to go ahead and work with it, wants to go, hey, you know what? Let me see what's here. Let me look through Mr. Michael's code. What's around here? Okay, integer. I don't know what that means. She's gonna go like that. She don't know what that means. So what I do is we leave messages for her so she could go through it and go, oh, okay, so that's what Mr. Michael left. We won't be using it too much, but I only have it here so you guys could, because you guys are programmers today, and you are going to be able to read through what this does. And also we commented out, so we don't want to have a bunch of print this, print that. We don't want a whole bunch of stuff on our screen, so we just do that so it doesn't get in the way. Excuse me. All right, so that's for that first part. Now let's go ahead and go through floating points. So floating number, floating point number. It's nothing more than a number between one number and the number next to it. I want you to think 3 and 4 and 3 point something because it is point something. We're just in the middle. We're not three, we're not four, we're kind of floating in between. That's the way to look at it. Think of it floating. You're just in between those numbers. You're not all the way in. then that's how that is going to work out. So if I wanted to, same thing, we print out floating. Oh, actually, now I copy and pasted. Let's do that. Floating number. Of course, in order for it to work, you need to have them match. If they don't match, will not work. So heads up for that. So we'll go ahead and have that floating number right here. My float example is 3.14. No pi number, actually. Speaking of which, we could rename that to pi number. Let's have fun with that. There we go. Pi number. We print it out again. Right here, pi number 3.14. And same thing here. Maybe I don't want to have it to be floating number. It's better to name things like explicitly, so I would just say pi. Actually, capital pi. Or erase this one. There we go. Makes it way easier. Instead of typing 3.14 over and over and over and over again, we can just type pi, easy. That's the way we want to work things. Pi, this is the name of our box. I'm throwing 3.14 inside it. That's all we're doing over and over. And on to our last two variable types. So string. Now a string is nothing more than a bunch of words. So right here, for example, I have here, we look through it. We actually go ahead and comment this code out. So string. Strings are nothing more than sentences. They're sentences, they're it could be one word, one letter. As long it's basically just characters. It's just text. And you use that text. So if I want to say, well, my main, for example, let me actually rename this to name for this one to be more explicit. So I have name here. I want to print out my name. And in this case, because I had I had this name tag right here, kind of put up on the screen. It is M Wazowski, and the little thing on the bottom, Mike Wazowski. So I'm gonna say my name is. I'm gonna say my name is Mike Wazowski. So instead of always typing Mike Wazowski, just because that's a big old name, long name, we don't really want to see that there. Uh, and it's annoying. Again, you're always typing the name Mike Wazowski, Mike Wazowski. Just type the word name, get a variable type, call it name, and then put whatever name you want it to be. And the same thing every time you print it. String example, Mike Wazowski. Now, writing's not fun, but writing code is. All right. So having fun with that, and our last one. This one's a very, very, very simple example. So right now, this is what we call a Boolean. So Boolean, it's a funky name for what it means. Booleans just means true or false. Nothing more than that. We use this to say, the only thing I could come up for right now, but I do have another example, and this is actually where our NXT part's going to come in. So it says right here, is sitting down equal to true? So I'm saying, am I sitting down right now? So this video, I am sitting down. So we would say that's true. And so all of this is just display whether it's true or not. There we go, true. Now, if you notice, this is a little different. Here, we would be using, uh, for here, well, no, not really, not too different, but it would go ahead and just show it what it is here, what it is here. But this is just simple as that, true. All right, you know what? Pretend I'm standing up. I'm not sitting down. Oh, there we go. I'm not sitting down. I'm standing up. I'm running. I'm doing something else besides sitting down. So it's just checking. All it is checking whether I'm sitting down or not. And there we go. Boolean example is it's false. But let's say this. Now, this is where our NXT part comes in, right? I'm going to go ahead and kind of merge these two now that we got to this part. This is where I would go ahead and now start to bring them together. So our NXTs, all right, our NXT, here's the NXT. We're going to connect this to our computer and we'll upload that in a bit. And so let's see, integer, let's call it speed. All right, this is going to be, oh, actually, we'll call this motor underscore speed. Now we're going to start playing with this around. I don't want it to go this far. When we're working with our NXTs, our motors right here, they have a power between 0, meaning they don't move at all, up to 100, where it's the maximum power, meaning it's the fastest it'll go. However, everybody, because from experience with our motors, we don't want them to be 100 because when they're 100 and you have them run, after a while, running and running and running and running because you're putting it to its max, you want to have this be from either 0 to 75. For all of us, it's going to be 75, so we do not burn out our motor. Very expensive. So in this case, I want the motor speed to be 75. Now that I know that, okay, now we know our motor is going to be going at a speed of 75. So that's gonna roll. Our floating numbers, well, in truth, we could use the floating numbers for the motor speed, but we don't use it as often. This is more for like special conditions. Now our name. This is the next thing I want to do. Our name. What's gonna be the name of our robot? We're gonna call it Grasshopper for this one because that's what we're gonna be building. A grasshopper. Actually, you know what? We'll just keep it as name and we'll just rename we'll rename it to Grasshopper. Because you see, I got lazy. I don't want to type Grasshopper over and over and over. It's annoying. We just go ahead and we just type in name. That's way easier. 4 letters. And that means Grasshopper. And then our true or false. Now here's the next part we're going to be doing, and that is motor underscore on. Well, that's it. Like the motor on, it's pretty straightforward. Is it on right now? Currently how I have it. Let's look at it. If I run the code on the NXT and I say motor and I press it, automatic because in our code here, it says false, meaning that all the it won't even move. That's usually how that works. But if I wanted to turn on, you want the motor on to be true. And that's how that is gonna go. All right. So that concludes this session. Very short, very straightforward. I am teaching this to assuming that these kids have never seen code in their life, don't understand it. This is the way how I would somewhat approach it, starting with very fundamentals. Now, um, but like I said, but now I'm gonna go ahead and answer the video. I'm gonna have timestamps at the beginning, so where or in the description for it. So this is where the other half is at. So, all right. So what I have in my notes. Again, I don't have any of the actual things. My goal is to use what's around me for that. And I hope that worked out well. So let's actually go through some questions that I've answered based on your through the messages on Indeed. So let's see here. So number three, answer these questions. If I were teaching an actual class, how would it be different from the video demonstration in two? It looks like it. Oh, uh, where the camera? Okay, yeah. See that? Demo teaching. Got that one down. Now for part three, that's where we're going. So these are some questions that I saw that you had on here. But we're teaching in an actual class. How different would it be from the video demonstrated? So the difference between teaching on video and here is because it's a wider range. The challenge to it is, of course, I'm only from this video, I'm one-on-one. Because I am going to be in a wide classroom, I need to make sure all students are accounted for and are on the same page. So this was a very fast-paced video, of course. So like in midway, interrupt me and be like, "Hey, what does that mean? What do you mean by this? Oh, I didn't get that." So you would kind of have to backtrack a little and try to find a way to kind of wiggle room that missing piece into it. Um, So the way to do it is just kind of slow down after each one is like everyone get it, take the time, about like a 5 minute, hey, like if they're rows, like most classrooms are rows of it. What I would used to do when I was in high school, I would kind of walk around and be like, hey, go this row. Hey, anybody, hands up, hands up here. Hey, you got it? No, you didn't get it? Hand up. Okay, run quickly. All right, what confused you? But we would do it after, of course, because it's like a 5 minute thing. Usually most students say I mean, of course, everyone has their own speed at learning. But say, for example, I start with the integer portion. Okay, does everyone kind of get that? You kind of scan through. What do you mean by this? The one that always takes the longest, always usually will be when introducing uh, a new subject to a class. So That would kind of be the only difference to it is that with a classroom, I'd have to take the time to look at everybody that's around. And if anyone that needs a little confused, uh, some students don't raise your hand, some aren't. So you kind of have to take that time to kind of monitor. And of course, that's where I have this little example thing. Like, okay, go ahead and take the time to write your name. While everyone's doing that little activity, it's very hands-on for them. And while they're hands-on, if they're struggling, that gives me the opportunity to go, okay, you're not getting it. All right, let me go ahead and make it work. Because code, what's neat is that when you're teaching code, code is very strict. And when it's wrong, it shows that it's wrong. And then you could kind of take the time to debug it for them and go, oh, let me see what you did here. Oh, that's what you did. So see this, that like right here, for example, the first one, this motor speed, you're not actually matching it with integer. That's where your error is at. So what you need to do is you need to go ahead and get this to here. That way it displays your motor speed. It's VS Code, so it shows it. So it's that's how that first way would go. That's how that goes in it. Let me see. So through your second part, how do you work in a diverse classroom with a mix of students who pick up fast and those who may need more support? How do you keep all students engaged and challenged? All right. So I'll go ahead and snack onto this one. So I'll start with how do I work with a diverse group of kids? So from a diverse group of kids, usually the way I start to see it, again, so of course everyone works at their own pace. That's something that's like that in every classroom. When we work with that, again, one of the things to do is take the time and kind of look at, all right, this student is struggling. All right, let me kind of see what it is. If it's a common thing where it's like, what do you mean that's a story? It's like I can't understand how this is a box and then I throw in stuff in here after throwing a name tag and then another thing. Maybe what they'll do is they'll try to attempt, okay, like the my name, like the string one, they'll throw a string and an integer. And that isn't gonna work. They're gonna go, why is that? Then I kind of have to go ahead and backtrack into what I said and say, oh, you know what? This right here that I just talked about earlier. So just to be clear, it's only one type at the moment. We're not there yet where we work with multiple. We're only going to be working with just one type and it only holds one. So per data type, it's going to hold one value at a time. So that's something that I'm probably going to have to go back on, kind of rev reviewing back, kind of thinking about it. That'd probably be one of the common questions I'd see because I'm always using the same box and using the same thing and I'm giving it a different value, that's kind of how it would be. To keep student engaged, so tutoring, when I was tutoring code or when I was working with NXTs here, well, before I started getting the NXTs, when I was teaching code, one of the things that I would do is basically I usually try to have this little like, oh, connection. Well, before we get into, hey, what are some things you like? The common thing that most students come in when it comes to coding is always going to be video games. So I guess I don't really have any video games to show around. Why not? I'll be like, hey, we'll look at video games. Oh, what game do you like? In this case, I'll just say this one right here. Oh, this one's this guy. It's open world. It's open world. There's dragons. There's all these things. I go, okay, cool. All right, so let's take it little by little. All right, so let's make a feature. What's a feature or what's something in the game that you like to see? And most of the time, I guess for this case, because it is an open world one, this one I actually had a student that referred me this one, and they're like, "Oh, I wanna make him walk around and everything, or I wanna make the inventory, or I wanna have a combat system, whatever they want to have." We kind of break it down. We go, okay, so now that I kind of see their interest in it, you boil that down into because as a programmer, um, part of the ways that we do in programming is you don't look at something head on right now. Like you can look at your phone, you can look at an application on your computer, and you can go, okay, yeah, you just click it, you don't think about it. Programmers, they gotta have to take the time to go, okay, what makes it run? What's the programmer that made this application use? Is it dictionaries? Is it lists? Is it what variable types are we working with? Are we working with booleans? How many booleans? That's usually the way we look at it. But in a game like how I showed you, they wanted a combat system. Okay, yeah. So in this case, we would have two things. The is our player fighting? And then that's kind of how you hype them up for it or get them engaged. Like, hey, all right, now that we get that, what if I told you we're gonna make a feature from that game, but in a very basic way through coding? And then from there, the way how I showed an example, the way how I did it was I showed you the actual core values of it, the core variable types, and I would go, okay, this is a name, this is an integer, um, this is a floating point, this is a Boolean. Now, Booleans are, I think I was like 4 or 5, I didn't count. Um, but point being is, okay, now that you know what a string is, all right, what are we gonna call our, now we gotta get our player. What is this player gonna be? Well, we just give him a name. We just call it player one equals and then a name. And then another one, enemy. Enemy one is equals skeleton, something like that. And then you would move on to another thing. And then from there, true or false. Is the player fighting? Is the skeleton hostile? You start to kind of you rename everything and then they start to kind of pick up because you make what you first taught as the kind of like boring way into it. And then you start to kind of get them like, oh, okay, I see how that works. You just put one and one together. You just change this, oh, you keep that. And then they kind of add on to it. Sometimes students will even add on, they'll go, maybe I want to have a car. Is the car on or off? What kind of car is it? And then they kind of start to kind of play it. It's giving him that freedom and that connection that will keep him engaged. Midway, I get, and that's where that challenging part comes in that I gotta see. Let's see. How do you keep all students engaged and challenged? Now, depending on what we're working on, usually it's going to be the NXT. All right, so I'll say something. In this case, or Spike, excuse me, I confused NXT for a different thing. So let's say our motor, right? Our motor, after we kind of get the motor portion, which is usually going to be like, if it's an hour class, I believe that maybe by half hour we would get through this chunk just to kind of make sure everyone's on board. Then we just play around with the motor. The motor, how I would do it is be like, okay, now that you know how to make it forward, how do we make it backwards? And then you kind of just leave them at it. And more than likely, I haven't read the documentation, but I believe you would just go on the negatives. You would go negatives, or if it's something like Scratch, I believe that you would have the arrow keys that go forward or back. But maybe it isn't. I haven't read through it, but that would just be the challenge. Okay, now that you know that it goes forward, how do you make it backwards? And then you just kind of leave it at them to kind of meddle around. And while they're working on that, it gives me the opportunity to go around and find who is not at this stage yet and who's struggling with data types, as an example. All right. So when on computer, I'm going to move on to the next one. When on computers, students get distracted to play games or browse around. How do you grab students' attention and make sure that they are on task and paying attention? So this one's usually pretty tricky. Uh, I've had some students where they would go ahead and have this issue of, not being engaged. Now, not everyone is always going to be excited to learn this because it's just not their type, but trying to figure it again, the way to do it is more finding that connection into what they like into this. Again, most of my students that I've had have always been into video games. I ask them, "Oh, what kind of video games are you guys into?" "Oh, okay." You kind of take the moment to talk, like let them talk, find any key details to it. If not, you just kind of come up with your own that's related to video games. That's kind of how that would work out. But to keep students engaged on it, because they're students, they're usually younger students that I work with. The most difficult part would have to keep their attention, but it's because some students they're very hyper. So you almost need to have this kind of bite-sized information and then have them engage. Bite size, engage. So that's going to be the challenge to it. But unfortunately, because it's bite size, some students don't pick it up, and that's where I would take the time to have students work on their own, make their own little example, have them play around with what I just taught them, and that gives me some time to kind of wiggle around the classroom. Hey, you good here? Hey, does this make sense? Are you confused? Or even midway during the classroom. I feel like that catching up. I understand is working with middle schoolers. Most middle schoolers kind of pick up, they kind of understand, hey, I'm in a classroom. Uh, but to kind of keep them engaged, that would have to be the ways to have some sort of connection into what they like. Uh, that does take some time, I understand. And in an hour session, it isn't always going to work out. But that's kind of the way to do it is to kind of keep it bite sized and then have them engage. Because short attention span, or some kids are just hyper, that's what have to be the way to do it. Midway, they're like playing, be like, hey, let it give the example and then kind of come back to and be like, hey, hey, like can't be playing. You kind of have to be a little firm with it. Be like, hey, I need you to be off this site. I need you to be back on track. Come on, show me what do you show me what we just talked about? No, okay, here, and then keep them engaged, and then have everyone um I would kind of have to have a little like mini session. Okay, hey, stick to here. I have it on the board or I have it, wherever. I may have I don't know how the classroom's gonna be, so assuming maybe there's a I don't know, stream and be like, hey, try to follow this code that I have here, or hey, follow through. We'll get into something better in a bit. And it's just kind of uh showing them in the long run we're gonna be making something move. I think and also thinking about it through, one of the ways that you would keep your students engaged on it is to actually show a finished project and then have them and then show it to everybody. Be like, hey, this is what we're gonna do, and this is what I did, and this is what we're gonna do today. And that's kind of how that will go. Usually, when you show something that's like robotics like that to a kid, they're always very excited. They'll be like, "Oh, this is cool. Oh, this is fun." So that's how that'll go. Let me read one more. Um, and I did say it. I did say the uh, or actually no, sorry. I did say what school I wanted to. Uh, that you asked me about the school. Kind of reading through some messages to clarify. I am a student at Orange Coast College. Might be one of the Golden West because I'm kind of going through a moving process. Place is almost empty, so there's that. But yeah, yeah, I'm a student at Orange Coast College. I'm a computer science major, and I am minoring in mathematics because when it comes to coding, they go pretty hand in hand. I've worked on some video games with it, and one of the things would have to be so. I worked in Unity. I mostly focus on that. I had worked at a location where I had tutored students before, and they go through a certain like steps, but um, after a while they make their own game, and they will use the Unity engine. I've been working at Unity since high school, so I play around with that occasionally. But because I started doing that, uh, I kind of had to start putting my mathematics skills and keeping up with documentation for that. And again, it's the same thing whenever because I've mostly worked with that. I'm always learning something new and I'm always figuring out. And with NXTs or with Spike, the thing about coding programs is that when you understand one, everything else is very similar. So with Spike, I haven't I saw that's Python, but the coding for it is very straightforward too. Um, and I believe that I could definitely show some students how to make something work. Of course, is that there is going to be that balance between students that aren't engaged and are engaged, that are exactly too they aren't interested, but it's finding a way to kind of be like, okay, think of it this way. Oh, you know what? Look into like this, or they're just absolutely not engaged to be like, hey, come on, we'll finish this up, and then we'll go into something cooler. Usually, you always want to excite for the next class. Hey, something better is always going to come because that's how that's usually how most students end up being in our. So look at this. Reading messages for that. That's usually how it is that you have to get some students engaged. Hey, something better is always going to come. Let's see. Reading through students engaged. I don't think I really went to for your sorry for your third one where not third second question on was it the second question? I'm sorry, I'm trying to find it. But it was something about challenge. Okay, how do I challenge them? Yeah, it's either make the motor go backwards. Maybe you wanted to maybe you go an extra step because it's I think it's scratch. It would be like motor turn this way, motor A on, motor B on. So I would have something like, okay, try to make the motor go one on, one off, and then you kind of make it. Now the trick to what you want to do is you want to have your robot kind of do, okay, turn this way, and then this way, this way, this way, this way, this way, and then they kind of start to pick up on it when you have them understand the fundamentals. You add a little extra step and you have them do that extra step is how you would challenge students. Uh, that's the way I did it. That's the way how I would do it. And looking through it, I believe that's about it. If you got any questions, contact me. I'll leave my contact information again, and I will. Uh, if you're up to this point in the video, uh, I'll leave timestamps to like the first half, second half of answering, of going through the mock course or mock classroom session, and this one. What's the point of saying at the end? But I just thought I'd let you know why I sent these timestamps. Thank you very much. I hope to hear from you very soon.